Today's lesson is just a review of all of the polynomial operations. We're going to do adding, subtracting, multiplying, and a little bit of dividing. So for the do now, what I want you guys to do is just simplify each of the expressions 1, 2, 3, and 4. Pause the video, take 1 to 2 minutes, and do that, please. So looking at number 1, we have to combine like terms. I'm going to look at the like terms here. A set of like terms would be the 3r squared and the 12r squared. Another set of like terms, if we look at the r to the minus 9r and plus 7r. And the last like term, it doesn't have an r like term to add to, would be the minus 15. So when you combine those like terms, 3r squared plus 12r squared would be 15r. 15r squared. Combine the r's, so minus 9r plus 7r would be minus 2r. And then there's no like term to go with the 15, the constant. And you want to do the same thing for every single one. So you don't have to highlight. If you don't have a highlighter, you could underline like terms and then maybe box other like terms in. We'll say the constants will box in, and then we'll just leave the y's, the other like pair of like terms, by themselves. So we would combine the y squared, so we get 6y squared. We would combine the y's, we get plus 11y, then minus 9 for the constants. And this last one, what's different about 3 than number 2? Number 3, instead of adding, we're subtracting. So it's important when we're subtracting to distribute that negative to every term in that second parenthesis. So I'm going to rewrite this. It's going to be 5y squared minus 7 plus 2y. And then we change the sign on every single term in that second parenthesis. So that'd be minus 9y plus 2 minus y squared. I see so many mistakes with that, so make sure you guys are good with this distributing of that negative to get to this. So now we can combine like terms. We have the y squared, that'd be 4y squared. We have the y's, minus 7y, and we have the constants, minus 5. And that would be our final answer. So, vocab breakdown. Let's talk about standard form. We're always going to want to leave our answers in standard form. Standard form is the degree of each term decreases from left to right. So I'm going to give you an example, and I'm also going to give you a non-example. So here's an example. We have 5x to the third plus x squared minus 15. Do our exponents decrease from left to right? Let's check. 3, 2, and then there's no exponent with the x, so that is in standard form. And let's look at a non-example. So how about we'll do the same thing. 5x to the third plus x squared minus x to the fifth. What makes this a non-example? Well, take a look. Our highest degree is at the end of 5. That should go out first. So if we want to put this in standard form, it should be negative x to the fifth plus 5x to the third plus x squared. So that is not in standard form. It is once you fix it. So I want you guys to read this example and take a minute or two, explain your reasoning. Do you agree with Jeremy? Make sure you explain incomplete sentences or one sentence. So it says Jeremy finds the difference. He's simplifying an expression. He finds this to be the difference. And he states that the leading coefficient is 5, because that's the first coefficient stated right there at 5. Do you agree with Jeremy? Well, in order to say it's the lead coefficient, we need to put our expression in standard form first. So let's first put in standard form. Our highest degree is 11x to the fifth Then the second highest would be plus 5x to the third plus 15x minus 8. So therefore, our lead coefficient is not 5. It should be 11. So do we agree with Jeremy? No, because Jeremy did not put the difference in standard form. The lead coefficient is 11. That's it. Let's go to the next page. So on this page, we have 4 questions. When adding and subtracting polynomials, when you see questions involving adding and subtracting polynomials, I just want to make sure you guys are good with the wording of them. So I just want you guys to do these 4 questions, these 3, and the 4th one on the bottom of the page. So pause the video, 3 to 5 minutes, and play it again once you are done. So take a look at the first one. It doesn't involve, we're not adding or subtracting yet. So this is an expression with the 5th degree. So 5th degree means the highest degree is 5. We could cross off 2 and 3 already, because those are, 2 is 6th degree, 3 is 7th degree. It is written with the lead coefficient of 7, so that means, well, 1's out. It has to be 4. 4 has the lead coefficient of 7. But let's keep going. And constant of 6. So the constant has to be plus 6. Well, the only one with the constant of plus 6 is number 4. So that's the only one we need to read, actually. But and express this expression in simplest form. Make sure you change every single sign. Distribute that negative. So this changes to addition. Then we change the sign on every single number, every single term in that second parenthesis. So now I'm going to highlight the like terms, 3x squared, positive 2x squared, plus 4x, plus a negative 4x, and then minus 8, and plus a negative 2. So when we combine those like terms, the x squareds become 5x squared. The orange terms, the plus 4x and the minus 4x, cancel out. And then the green terms, that would just be minus 10. That is in simplest standard form. So we're good with that one. Let's check out the next 2. So if a is equal to that expression and b is equal to that expression, then what is a minus b? It is so important here. This is a mistake I see a lot of students make. They write it like this: 3x squared plus 5x minus 6 minus 2x squared minus 6x plus 7. What is wrong with that? A couple things. So notice the minus sign here is this minus sign, but you're also, the way I wrote it, I'm also counting it as that minus sign. So that is incorrect about this. Also, what is also incorrect about this is we're subtracting all of b, not just 2x squared. So the way you want to write this is you should plug in a. You can plug in parentheses if you want, but the one you want to make sure you plug in with parentheses is b, because that's what you're actually subtracting. So it'll be 2x squared minus 6x plus 7. And you'll see when we do that, that negative gets distributed to every term in that second parentheses. So that would now be 3x. Nothing happens to that the first 3 terms, but the b is the one that changes to be plus 2x squared plus 6x minus 7. So when we combine like terms, we have 5x squared plus 11x minus 13, which gives you choice 2. That's a tricky part about subtracting polynomials, is That right there is making sure to remember to distribute that negative. And the second part, the last question on this page, subtract 5x squared plus 2x minus 11 from 3x squared plus 8x minus 7. So this all comes down to subtracting a value from another value. If 5x squared plus 2x minus 11 is the one being subtracted from 3x squared plus 8x minus 7, that means that 3x squared plus 8x minus 7 is first, and you're subtracting 5x squared plus 2x minus 11 from that polynomial. So make sure you distribute that negative all the way through that second, inside that second parenthesis, so that'd be minus 5x squared minus 2x plus 11. Combine like terms, you get negative 2x squared plus 6 plus 4. And that would be result in a trinomial. That is 3 terms. 1, 2, 3. Good. We express as a trinomial. And that is our answer. Let's go to the next page. Multiplying polynomials. So we're going to do the first 3. We'll do the top 3. The big thing about multiplying is make sure you distribute that number to every single number in the parentheses. So here we have 4x being multiplied by not only 5x, but also 6. So that it would look like this. So 4 would be 5x times 4x plus 6 also times 4x. Yeah, make sure it's getting multiplied to everything inside the parentheses, which would give us 5 times 4, which is 20. X times x is x squared plus 24x. And nothing's changing with that second one. We still need to multiply 2x into every single term in the parentheses. So 6x to the fourth gets multiplied by 2x, minus x to the third gets multiplied by 2x, and the plus 5 gets multiplied by 2x. And when that happens, you get 6x to the fourth times 2x, so 6 times 2 would be 12. X to the fourth times x, it'd be x to the fifth. Negative 1 times 2 would be negative 2. X to the third times x to the fourth, plus, finally, 10x. And that third one, we need to double distribute here. We have a binomial times a binomial, so 7 needs to get multiplied by 10 and 3x, and then negative 2x needs to get multiplied by 10 and a 3x. So you want to make sure you do 10 times 7 plus 3x times 7, and then make sure you also multiply that negative 2x, so that'd be plus 10 times negative 2x plus 3x times negative 2x. And multiply them, you get 70 plus 21x minus 20x minus 6x squared. Let's combine like terms and put this in standard form. So the negative 6x squared gets put out front. The 21 minus 20x becomes plus x plus 70. And that would be our simplified answer. I want you guys to do the next 4 and take the next 3 to 5 minutes to do the next 4. Take your time. Make sure you multiply everything correctly and multiply everything by what it should be multiplied with. Pause the video and replay it when you're done. I'll show you the answers once you're done. Here are the answers to the next 4. Make sure for the first one you have all 4 terms written out here, so you multiplied every term on the left by every term on the right, and then you simplified it from there. For the second one, check your exponents on those C's and the D's. Make sure they have the correct exponents. I cannot stress this enough for the third one. I see so many people make the mistake of just bringing the square in and saying, oh, that's 16x squared plus 9 or minus 9 or something like that. Don't ever do that because incorrect. You're forgetting about the middle two terms here. They don't cancel out. So please, I'm going to tell you right now, you're going to make this mistake. I hope you don't, but I see almost every single student make this mistake. In order to not make this mistake, please write it out like this. You do 4x minus 3 squared would be 4x minus 3 times 4x minus 3. Please write it out like that, because then you'll see it's a question like the first one we did, which is double distribution, and you won't forget that middle term. If you don't write it out like that, 99% of the time you're going to forget that middle term. So please write it out like that. Please, please, please. I can't stress that enough. I see it all the time. From the beginning of September to the end of June, I put that question all over every single unit, and there are still people every single time get that wrong. So please write that out. Enough about that one. And the last one, make sure you multiply everything on the left by everything on the right. So we have, instead of the first one where it's just a binomial times a binomial, we have a trinomial times a binomial. So we're going to have more terms to combine at the end. Let's go to the next page. So when we divide polynomials, this is not full polynomial division. It's you'll get that later on, but this is just it's a little simpler polynomial division. So when I look at the first fraction, the big thing for division is that we have to make sure this 4, we divide 8c squared divided by 4, and also 12d squared divided by 4. So it's very important that we divide every term in the numerator by the denominator. So in order to show that, I'm going to split up this fraction into two fractions. So that would be 8c squared over 4 minus 12d squared over 4. And by doing that simple step, it's going to allow me to not make a mistake I could potentially otherwise make if I don't split up into two fractions. So from here, now I can simplify. I see the 4 and the 8 cancel to 1 and 2. And the 4 and the 12 also cancel to 1 and 3. So my simplified answer would be 2c squared minus 3d squared. I want you guys to do the next two. Take 2 to 3 minutes. Pause the video, do the next two, and we'll go over it once you're done. So this next one, I'm going to do the same exact thing. I'm going to split this up into two fractions. So that'll be 16t to the 5th over 4t squared minus 8t to the 4th over 4t squared. Now I can simplify 16 and 4, that becomes 4 and 1. 8 and 4, that becomes 2 and 1. Then t squared cancels out here, and I'm left with t to the 3rd. And then t squared cancels on the denominator in that second fraction, and I'm left with t squared in the numerator. So this now becomes 4t to the 3rd minus 2t squared. They're both over 1, so we don't need to write that. And that would be my simplified final answer. And you would want to do the same thing with that third one. So that third one, simplify it into two fractions. That would be 3ab squared over ab minus 4a squared b over ab. And we're going to cancel out what we can. Common factors in the numerator and denominator. So the a's cancel out. This b cancels out with one b on top. A cancels out with one a in the top for the second. And then the b's cancel out. And we're left with, at the end, 3b in the first fraction minus 4a in the numerator cancels to 1. So that is our answer. So make sure when you're dividing, you split up that expression into all the potential fractions that it is. That is really going to help you not make errors down the road, because everything in the numerator is getting divided by the denominator, not just 1. So what I want you guys to do next is just the classwork, is all polynomial operations. And that's it.